Hello. To master the next standard, which is standard A3b, we are going to learn to calculate the rate of change of a linear function that is represented in a table, graph, or algebraically, or in a mathematical and real-world problem. Before you start your work, make sure you name your slides with your full name and share them with me as an editor. And when you finish your work, make sure you submit the website link to your slides in the Canvas assignment. You're going to open the video, which you are already doing because you are already watching the video. And if you need to split screen so that you can watch the video and type on your own slides, press Alt and the left bracket or left curly brace. So let's begin with a couple motivating examples of why do we need to know rate of change. So one example is that John wants to save some of his allowance money that he gets each week to buy the new PS7, which costs about $2,000. If John knows that the PS7 comes out in 8 weeks and he already has $200 saved up, what amount does he need to save each week in order to buy the PS7 when it comes out? Look at that PS7. Looks really new and innovative. Another example of needing to know rate of change. Let's say Amaris just won a $500 gift card to Bill Miller's, and her favorite meal costs about $13 each, and she goes there to eat once a month. How many months can she use her gift card until it runs out of money? So there is some chicken strips and a sweet tea. Well, in order to answer these questions, we need to understand what rate of change is. So let's begin with a definition. The definition of rate of change is the result of division between the change in the output values of a function by the change in the input values of a function. The rate of change is division between the change in the output and the change in the input. And we can calculate the rate of change between any two points, coordinate points, because we know that if you take 2 points, you can draw a straight line in between those 2 points. Now, you should know by now that in a function, every input has only one output. So let's create 2 points with an input and an output. So I'm going to take this point to be my first one. It has an input of x1 and an output of y1. And we're just using those footnotes, which are these little numbers down here, so we can keep the variables separate from each other. Our second point is x2, and it has an output of y2. So looking back at our definition said that rate of change is the result of division between the change in the output, which are the y values of a function, by the change in the input, which is the x values of a function. So here we are, we have our 2 points, x1, y1, x2, y2. And we know that change is just another word to describe subtraction. If you've ever bought anything with cash, you know that the cashier will subtract the total amount from the money you give them, and that is your change. So change in the output, which is the y values, would mean subtracting y2 minus y1. And change in the change in the inputs, which are the x values, wow, a lot of mistakes here, would be x2 minus x1. So again, change means subtraction. So we're subtracting the 2 output values and we're subtracting the 2 input values. And again, we know that our definition says that we have to divide these two things. So our rate of change formula becomes the change in the outputs, which is y, divided by the change in the inputs, which is x values. Come on, cauliflower. Change in inputs, which is the x value. So that is equal to y2 minus y1 divided by, which is this line, x2 minus x1. This is equal to rate of change. So again, this line here is division. And looking at another example of this, we have a nice graphic here. Given 2 points, x1, y1, and x2, y2 on a line, the slope of the line, and we're going to talk about what that word means, is this. So the rate of change is equal to y2 minus y1 divided by x2 minus x1. That is our change in y divided by change in x. And here's a picture of that. We have the change in x would be the length of this line here. Change in y would be the length of this line here. And we're finding the rate of change between these 2 points. So now that we have the definition for rate of change and the formula for rate of change, let's talk about a couple important facts to remember. The first thing, and quite possibly the most important thing, is the order we subtract in must match. And what I mean by that is, if you look at our formula, we always subtract y2 minus y1 and then subtract x2 minus x1. If we tried to do y2 minus y1 and then x1 minus x2, we would not get the correct rate of change. And likewise, if we did y1 minus y2 and then we did x2 minus x1, we would not get the right rate of change. So make sure you're always subtracting in the same order of your y values and your x values. And remember that these are coming from the same point, and these green ones are coming from a different point, but the same. So the second important thing to note is that rate of change is also called slope, or often called rise over run. So if you look at this picture here, slope is the vertical change divided by the horizontal change. Well, that is the amount the graph is rising divided by the amount the graph is running, meaning going back and forth across the x and rising, going up and down. And the reason we say slope is because you could compare this line to something like a mountain or a road in that it is not flat. So it has some kind of slope to it. The third important thing to note is that we use the variable m to represent slope in mathematics. M as in, I love slope. So here in this picture, you can see that the slope of the line through the points x1, y1, and x2, y2 is m is equal to rise over run, which is equal to y2 minus y1 divided by x2 minus x1. So now we have many different ways to think about the definition of slope and the slope formula. Your task is to answer these 2 reflection questions. Number 1, what is the formula for rate of change, aka slope? And 2, describe slope in your own words. Don't forget to submit the link to your slides when you are done.